In this video, we will look at data types in SQL. There are many data types in SQL, and it is important to identify the correct data type for your data. There are also different data types to store the same data, so we will see when and what kind of data type we have to use to store our data. So, let's start the video. Numeric data types. First of all, we will see numeric data types. Our first one is bit, where bit is available on the first number. Bit can store integer 0 and 1. It is also used to store Boolean values. Then, we have 4 data types which are used to store integer numbers, but these data types differ in their sizes. We have a tiny int that will use 1 byte storage space. It means we can store a total of 256 characters in it. Its range is thus from 0 to 255. After this, we have small int, which usually uses 2 bytes. Then, we have int, which has 4 bytes size, and its range is also very good. If we are in a situation where we need to store billions and trillions of records in a table, then we can use big int as a primary key. Big int's range is much bigger than the integer data type. But if we're in an opposite scenario, where we would want to save the RGB value of colors and its range is from 0 to 255, then why would we need to use an integer data type that has more than enough range? It would use up to 4 bytes of space unnecessarily. No. Instead, we would use tiny int here, because its range would fit our needs between 0 and 255, and it would only consume 1 byte, which is just what we need to save. This is just an example showing how important it is to choose data types that match our values and our needs. So that's it on integer data types. Apart from this, we also have the possibility to save floating point numbers and decimal numbers. Those are the last 2 lines in our table. In decimal, we need to define the limit of p and s, as you can see. P holds many digits in total, which can be on the left or right of the decimal point. Its maximum length would be 38 digits, and by default it is set at 18. S indicates how many digits we can place after the decimal point. There is no difference between decimal and numeric data types, so we can use either one of them. It's the same for floating point numbers. You can either use real or float. The only difference will be in terms of the range between types. Now let's look at our second table. Here, I have listed the money and small money data types. It is used to store currency values. However, I would not recommend that you use it, because its calculation is actually not precise. Instead, I would recommend that you use a decimal data types. We also have string data types. There are many string data types in SQL, and we will have a look at the main ones. First of all, we have a char data type, which is used to store characters. However, it doesn't include Unicode characters. For that, we will have a specific data type called nchar. Unicode is a world standard for text encoding. This coding scheme supports almost all languages and characters all over the world, whereas a normal character scheme would only support American English alphabets. Unicode is the only language that would include Chinese, Japanese, or Arabic characters, for instance. So, if you need to store this kind of characters, you will use Unicode characters and store them with the nchar data type. We use char or nchar when the length of characters is fixed. For example, if you're storing a CNIC number or credit card number, there is always a fixed length. However, if the length of your characters is varying, for example, if you're storing the field of a name and you have thousands of them, for example, for a big business, you will not be able to use the data type of fixed characters. Instead, you will use varchar and nvarchar. When we are not sure about the length of the word/value we are storing, we will use variable characters data types. Other data types include the following: text and ntext. These data types will not be used now. We will just use varchar and nvarchar. Binary and var-binary. In these data types, we can store any type of data. We can store text, you just have to cast it in binary or var-binary, but you can also store images, cryptography, and documents. The difference between binary and var-binary is the same as in between char and varchar. In binary, fixed bytes will be stored, and in var-binary, those storage bytes can vary. Their limit is also 8,000 bytes, but if you need more storage, you can use var-binary, open brackets, max, close brackets, which will store data up to 2 gigabytes. Image. Lastly is the image data type, but I don't recommend using it. Use the var-binary, open brackets, max, close brackets, data type instead of the image data type. That's my advice. Nchar and nvarchar. When the length of your characters is variable, you will use the data type varchar and nvarchar. We need to use field of variable character when we are not sure about the length of the word we are typing. Like our previous example, if we are using different names, we don't know about their length, and we can't predict them, so we need the variable character field. The basic difference between char and varchar is that in varchar, if you set the data type of column to 50 integers, and then you enter only one integer, then it will cover the space of 50 integers and cause errors. But if you're using varchar and your name is either short or long, the column will adapt to this, and it will only cover the necessary space. In other words, your risk of causing errors is reduced because extra space will not be used unnecessarily. Now, we will see an important element, which is the letter N, which is written with char and varchar. We call it the number of characters, but that's only partially true. If you look at Microsoft's official document, it doesn't mean the number of characters. It actually means the number of bytes of data a field can store. Usually, if we use strong English alphabets or numbers, each value consumed 1 byte. So if we limit our char to 10, it means the field can store the data of 10 bytes. If 1 byte is being used to represent 1 character in a field, meaning that only 10 characters will be stored in 10 bytes. In this specific example, n is the number of bytes, but it also works as the number of characters. But if you are using multi-byte encoding, then it is systematic that the number of bytes and the number of characters will cover the same space. For example, if you are using 2 bytes that represent 1 character, and define the field of char as 10, then the field will only store 5 characters instead of 10. So in the case of multi-byte encoding, n will not be equal to the number of characters. If you want to learn more about this, I will add some details in the description of the video. But for the sake of simplicity, we will assume n as the number of characters, and you will not face any problems because we will be storing in English. So, if you have no clue of what I've been saying for the past minute, ignore it. Just keep in mind that field of car and ncar will only cover the field of space which will be defined by you in a code. The actual data we have entered is less than the maximum limit of code. So make sure to assign the space in the code carefully, and don't waste space, which will be of no use. Now, if we take varchar and nvarchar fields, let's assume I'm using two columns in which I define data type varchar open brackets 100 close brackets in one column and data type varchar open brackets 1000 close brackets in the second column. Let's suppose I want to store my name, Abdul Rafay, in both columns. Both columns are taking the same space because the data length is the same, regardless of the fact that there is a huge difference between the data types of both columns. This is because we are using variable data types, and for variable data types, only the needed space will be consumed. But it's important to add that the limit of these data types is 8000. You can store a maximum of 8000 characters or 8000 bytes of data. If you ever need to store more, you can use varchar max or nvarchar max, which will allow you to store up to 2 gigabytes of data. Text and ntext. The text and ntext data types are not useful for now. We will just use varchar and nvarchar, so I won't go into more detail on this. Binary and var binary. In these data types, we can store any type of data. So this means that we can store text. You just need to cast it in binary or var binary. But you can also store images and documents. The difference between binary and var binary is the same as between char and varchar. Fixed bytes will be stored in binary, whereas variable bytes will be stored in var binary. Their limit is also 8000 bytes, but if you want more space, you can use var binary open brackets max close brackets, which will store data up to 2 gigabytes. Image. Lastly, we have the image data type. I don't recommend using this one. If you ever need to store images, just use the binary or var binary data types we just described. If we are dealing with data like date and time, there are many data types to store them. Let's have a look at them. The first data type is date-time. As you can guess by its name, it's used to store values of date and time. Now just below this one we have a second data type called date-time2, and which was introduced later. Its range and its accuracy are both better than date-time. The time is accurate to 100 nanoseconds. After this, we have small date-time, whose range is very low. Its accuracy is to 1 minute, and it can be stored in 4 bytes. So of course, compared to the first two data types, it's seen as low. If you want to store values of date or time separately, then you have the data types of date and time for this. After this, we have date-time offset, which is used to store universal time, so it offsets time zones. I recommend that you use this one instead of date or time. It's more practical to be able to account for time zones. Next, we have timestamp to store values with the same name. Most of the time, it is used to store data on concurrency and synchronization. So, these are the data types which are most commonly used in SQL. Of course, there are many more data types, but we won't discuss them here. There are too many, and we won't have any use of them. At least now you know the most common ones, so try to keep them in mind. In this lecture, we will discuss the insert key to insert data into tables that we have created in previous lectures. First, to use an insert statement, we will select the database in which our tables are created. Now, let's create one more table in database with the name book_detail. To this database, we will add ID in integer form, and this will be our primary key. Let's also add book titles with varchar characters open brackets 30 close brackets, and use the year as integer, and add the platform for publication as varchar characters open brackets 30 close brackets. To create this new table, we need to run the following query. Create table book_detail open brackets ID int primary key title varchar open brackets 30 close brackets year int platform varchar open brackets 30 close brackets close brackets. Now let's execute the query and click on the refresh button and open our database. If we go to tables, you can see on the screen that our table with the name book_detail is now created, and it includes the columns of ID, title, year, and platform, just like we wanted. Now, what's a table without our data? Let's try to insert it. Use the command insert into and then select table book_detail and add ID, titles, year, and platform. Our values will be ID 1, title SQL. We use varchar here, which is string value. Then we will use year 2022 and we will select platform Amazon. Once you have specified this data, we will select from book_detail and execute the query. The query is the following. Create table book_detail open brackets ID int primary key title varchar open brackets 30 close brackets year int platform varchar open brackets 30 close brackets close brackets. Insert into book_detail open brackets ID comma title comma year comma platform close brackets values open brackets 1 comma open quotation marks SQL close quotation marks comma 2022 comma open quotation marks Amazon close quotation marks close brackets. Select star from book_detail. After execution of the query, the result will be displayed in the form of a table. Now, if we want to add more data, we can execute the following query. Create table book_detail open brackets id int primary key, title varchar, open brackets 30, close brackets, year int, platform varchar, open brackets 30, close brackets, close brackets. Insert into book underscore detail, open brackets, ID, comma, title, comma, year, comma, platform, close brackets, values, open brackets 2, comma, open quotation marks, C++, close quotation marks, comma, 2022, comma, open quotation marks, Amazon, close quotation marks, close brackets. Select star from book underscore detail. Once again, we select the query and execute it, and the data will be displayed in form of a table. Now, if we want to add another batch of data, we can run the following query. Create table, book underscore detail, open brackets, ID int primary key, title varchar, open brackets 30, close brackets, year int, platform varchar, open brackets 30, close brackets, close brackets. Insert into book underscore detail, open brackets, ID, comma, title, comma, year, comma, platform, close brackets, values, open brackets 1, comma, open quotation marks, Java, close quotation marks, comma, 2022, comma, open quotation marks, Amazon, close quotation marks, close brackets. Select star from book underscore detail. After executing, we will see that all our queries are displayed in table form. It is not necessary that we add 4 columns in a table. It could have been any number, honestly. You could be in a situation where you only need 2 columns in your table. In such a case, your query would look more like this. Create table, book underscore detail, open brackets, ID int primary key, title varchar, open brackets 30, close brackets, year int, platform varchar, open brackets 30, close brackets, close brackets. Insert into book underscore detail, open brackets, ID, comma, title, close brackets, values, open brackets, 1, comma, open quotation marks, CSS, close quotation marks, close brackets. Select star from book underscore detail. Now, if we execute this query, you will see that only the data of 2 columns will be displayed, and in this case they are ID and title. We could also add specific data using a null key. If we wanted some null cells, then we would not add data in our query of values section. In the last lecture, we discussed how we can insert data to create our tables. In this lecture about SQL, we will see how we can use the select query. Select in SQL. When you open the Microsoft SQL Server Management Studio, a small window will appear and it will ask you for your authentication. If you have used a password, then it will ask you for your server type. Once you succeed in connecting, an interface will appear on your screen. You can see that on the top, it shows my server connection. And after this, my database appears with the name books_db. To this database, I have added 4 tables, which are dbo.books, dbo.books_detail, dbo.celebrity, dbo.sales, and dbo.student1. Now the question I will try to answer today is how can we select one of these tables from the database? If you want to do so, you will go to New Query. Quick reminder, make sure you select the correct database to run your query, in case you are using multiple databases. Here, we're only using one database, so our query will be select from books. If we execute this query, the selected table appears below the query section. Let's try with another example. Let's say we want to show the Student 1 table data. Then we execute the following query. Select from Student 1. The Student 1 table will be displayed. These are small tables to understand the concepts. But if you're working in a company, there will be huge amounts of data, so there you can't use single tables. You will probably have to target specific areas in huge amounts of data. In our simple example, we only want to see our customer's name in the sales table. The way to do so is to execute the following query. Select customer_name from sales. As you can see, the column we wanted to see with our customer names appears, which means that our query works properly. If you wanted to see the year only, then you would execute the following query. Select year from sales. After executing the query, the year column will appear. There is another concept I want to talk about. Let's say that we want to check records with specific limits. For example, we have records of 6 customers, but we only want to see the records of our first 4 customers. Let's say because they're our favorites. If we want to do so, we execute the following query. Select top open brackets 4 close brackets from sales. After execution of the query, only the records of our first 4 customers will appear. We call this method using select clause. We can also specify if we want to see data from customers that have the same name, but we only want them to appear once. We run the following query. Select distinct customer_name from sales. In our case on the screen, it's causing an error because there is a spelling mistake in data. Let's try with something else. Let's take our books data, and let's suppose we want to see the data of the same year only once. For this purpose, we will run the following query. Select distinct year from book_details. After execution of the query, the year 2021 will only appear once, because we specified distinct in our query. Now, that's it for selecting in SQL. Next lecture, we will discuss max and min in queries. In the last lecture, we've seen how we can select columns by using the select clause. In this lecture, we will see some more mathematical aspects of this. It will be a short lecture about the further use of the select clause. AVG, min, and max in SQL. So, let's start. I have already added another column named amount in our sales table and added some data in this column. We will need this for the query I'm about to run. Let's imagine we want to see the highest amount we have in this column. We will run the query by writing max and targeting the amount column, because that's where the information will be. The query is the following. Select max, open brackets, amount, close brackets, from sales. Let's click on the execute button. As you can see on the screen, it only displays the highest amount of our new column, which is 6,000. But it doesn't show the column name, which is not very practical. To solve this, let's run the following query. Select maps, open brackets, amount, close brackets, as amount from sales. Now, it will also display the column name and the maximum amount. Now, if we wanted to see the minimum amount of the same column, we would run the following query. Select min, open brackets, amount, close brackets, as amount from sales, and execute. And it will show the minimum amount, which is 500. We can also use this tool to see the average of the values in the amount column. Let's run the following query. Select AVG, open brackets, amount, close brackets, as amount from sales, and execute it. It will show the average of all the amounts, which is 2,916. We can also divide the values of any column. Let's suppose we want to divide the amount of our column by 3. Then we should run the following code. Select amount/3 from sales. If we execute the code, it will show the values of our column after the division. We can do this with any number we want. For example, if we want to divide the amount column by 10, we will run the following code. Select amount/10 from sales. In this lecture about SQL, we will see how we can use operators. If you are trying to learn more about SQL, it probably means you have learned some other programming languages, which means you also know about the use of signs and operators. Let's talk about those in the context of SQL. Use of where clause and operators with logic. Before using operators, I want to tell you one thing. In previous lectures, I showed you how we can select columns. For example, if we want to select the age column, we just have to run the following query. Select age from sales. When we execute the query, the age column is displayed as a result. Now, I only want to select the 4th row in our age column. To do so, we will use a where clause as follows. Select age from sales where ID equals 4. Now, if we execute the query, it will only display ID number 4 in the result box. If we wanted to display all the columns with ID number 4, we would run the following query. Select star from sales where ID equals 4. Now, if we execute the query, it will display the data of all the columns attached to ID number 4. If we want to display IDs which are greater than 4, we will use the help of an operator through the following query. Select star from sales where ID greater than sign 4. If we execute the query, it will display ID numbers 5 and 6 as a result. And if we run the following query, select star from sales where ID greater than equals 4. Now, if we execute the query, it will display ID numbers 4, 5 and 6 in result. And now, if we run the following query using the less than operator, select star from sales where ID less than sign equals 4. This time, it will display ID numbers 1, 2, 3 and 4 in result. We can also use the not operator here, which is as follows. Select star from sales where ID equals 3. Now, if we execute the query, it will display all IDs except ID number 3 in the result. We can also use logic in queries. For example, if we want to display all IDs that are less than ID number 4, and with the age greater than 35, and the amount greater than or equal to 2000, we must execute the following query. Select star from sales where ID less than sign equals 4 and age greater than sign 35 and amount greater than sign equals 2000. If we execute the query, it will show us IDs 2 and 3, which fulfill all the conditions of our query. If we selected 5000 instead of 2000 in the query above, it would have only shown ID number 3, because customer with ID number 3 is less than ID number 4. His age is greater than 35, and his amount is greater than 5000. So, this is the method to display data by using logic, according to requirements that we can decide upon. In this lecture, we will talk about the order keyword and how we can use it in SQL to display data in a chosen order to attain a better presentation. Order keyword. As you can see in our table, the data is displayed in its default form, without any order. But this is confusing to me, and now I want my data to appear in ascending form. In other words, I want the names to be displayed in the alphabetical order from A to Z. For this purpose, I will select the table in which I want to apply this order keyword. Then, we type the keyword order and add the column name, which is customer name. Then, we just have to select the form in which we want to display our data for now. It will be ascending form. The query of the above order is the following. Select star from sales, order by customer underscore name ASC semicolon. If we execute the code, the customer name column will appear in an ascending order. If we want to do the opposite, for instance, display our data from Z to A in a descending order, then we must run the following query. Select star from sales, order by customer underscore name DSC semicolon. Now, as you have noticed, there is only the customer name column that appears in ascending order. What if we wanted to change the order of the month, year, age, or amount? The answer is that you wouldn't have to do it because it will not work in the same table. Indeed, if you select multiple columns and want to see them in an ascending or descending order, the code will only apply the changes to the first column you entered in a query. The second column will stay the same. For example, if you use the following query, select star from sales, order by customer underscore name, column month, ASC, semicolon, the customer name data will appear in ascending order, but our month data will remain linked to our customer name column and will not display in ascending order. Now, if we use the following query, select star from sales, order by month, comma, customer underscore name, ASC, semicolon. Now, the data from month will be in ascending order, but the customer name data will appear as linked with the month, which are in ascending order. This is why you can't choose multiple columns to apply an order key. Only the first column will be affected. In the last lecture, we discussed the order keyword to change the appearance of our data. In this lecture, we will talk about null and is not null, or how we can find null or is not null values. Use of null or is not null. So, let's start the lecture. As you can see in our sales table, we don't have any null values, so we will change and select the book detail table. That one has some null values in it. In this table, we will apply our keyword of null or is not null. Remember that we also have to specify the where clause for the selection of columns. For example, if we want to see how many null values we have in the ID column of the book_detail table, then we will run the following query. Select star from book_detail where ID is null. When we execute the query, there is no result, simply because there are no null value in the ID column. Now, if we choose the title column and run the following query, select star from book_detail where title is null, it will display the null data of the ID column and its rows, because we already saw that the where clause allows us to also display the data of the rows related to the selected column. Now, if we select the year column and run the following query, select star from book_detail where year is null, it will display 3 IDs in which the year data is null. Now, if we choose the price column and run the following query, select star from book_detail where price is null, it will display all IDs because the price is null in all IDs. Now let's try to separate our data which is not null. We proceed as follows. Select star from book_detail where price is not null. This query will show the IDs which don't have any null values. Now if we execute the query, it will not show any data, because every price is null in our table. If we change columns and use the title column, for example, then the query becomes select star from book_detail where title is not null. Now, it will display the first 5 IDs in our result box, because ID number 6 has a null value in the title column. This keyword can be used wherever you want to find things that are